Hey everybody, it's Mr. Carr again. Today we're going to be looking at 9.2 day 2. Now we're going to be talking about volume of a pyramid. And then we'll also be doing volume of a cone as well. So when we look at a volume of a pyramid, there are some similarities to our volumes of prisms. We have this polygon base down here, and that is related to it. So when we do the volume of a pyramid, it is going to equal to the product of the area of the base, B, and the height, so we did H on that one, height of the solid divided by 3. So volume is area of the base times the height divided by 3. So remember, area of the base is talking about this right here. Height is going to be up the middle of our pyramid. So like where before we had to do our slant height, sometimes we got to be careful with that because when we look at example 1 here, we're given the slant height L here like that, the 30. But that's not what I want. I want the overall height. The overall height, I can draw it like this. So when I make that drawing inside the triangle, or sorry, inside the pyramid, I've created a right triangle here. And that right triangle, it's got a length of 10 down here because it's going to be half of the 20. Here's my H, and there's my 30. So what I can do is I'm going to start by taking H squared plus 10 squared and setting that equal to 30 squared. So we can solve for h by doing, we got Pythagorean theorem. So we got h squared plus 100 equals 900. H squared is equal to 800. And for our purposes here, I'm not going to bother breaking this down. I'm just going to leave it as the square root of 800. It's just easier to work with, like in terms of, I'm just plugging in my formula anyway. Okay. So now when I look through this, I'm going to kind of label my base, like what shape is it? So in this case, the base is a square. It would have been nice if they actually did a little bit more information about that, but we're going to go ahead and assume it's a square here. So base is a square, so that means the area of the base is going to be side to the second power. So in this case, that's going to be 20 squared, which gives me 400 square millimeters. So finally, we're just going to plug everything into our formula now. So that's going to be equal to area of the base times the height divided by 3. Okay, so I just plug that in my calculator and get my decimal number, come out to 3,771.24 cubic millimeters. All right. Next one we do is a cone. It's the same exact idea. Just like we did with our cylinders and prisms, a cone is going to be modeled after a pyramid. The volume of a cone is the product of the area of the base and the height divided by 3. So like we just did, we did base times height divided by 3. But also, just like we did before, instead of writing it this way, we can instead write it in terms of circles. There is only one possibility for B here, and that's going to be pi r squared times h divided by 3. Okay, so here for our example, we have what's called an oblique cone. Oblique cones, in terms of surface area, it makes a difference. That's why we always talked about right cones. So right cones means that like the tip right here is exactly above the center. But if I take this point and I shift it over here so the cone looks more like this is an oblique cone. Like the height of that cone is not right over the center of that circle. And in terms of our volume, has no effect on that. The oblique cone is still going to be a height of 12 and still my radius of 4.5. So it doesn't matter if we move the point here around like that, if it's on this oblique shape, it's still going to be the same formula. So in this case, I've got my radius is 4.5 and my height is 12. So I can just go right to my formula and make it pi times 4.5 squared times my height of 12 divided by 3. Okay. So plugging this in, and I simplified a little bit with my calculator, making an exact answer is going to become 81 pi, and this will be cubic feet. Okay. And if I want my decimal number, just plug it in and I get 254.47 cubic feet. Okay. And that is going to be it for today. So just make sure you're looking for height. That's the biggest thing about pyramids. You want to make sure you're using the height and not a slant height or any other side length on that one. Okay, so it has to be like in this case, it is right down the middle for the six. So that is my height of the pyramid. So that one's okay. With cones, kind of a similar thing because maybe I might give you information where it's this length here. So you got to make sure, well, and it wouldn't be for an oblique one, but maybe I give you the slant height here instead of the height. Just make sure you understand that makes a right triangle. So we typically will use like Pythagorean theorem to find that missing length there that we need. Okay? But that's it for today. So take care, everyone.